think we're going to get started here. Good morning to everybody, and welcome to the February 86 Virtual Users Group meeting. We have Brian Finley with us today to talk to us about big data solutions. Brian, I'm going to turn it over to you to introduce yourself and start off with your presentation.
Thank you very much, Kevin. So my name is Brian Finley. I'm the Principal Architect for Big Data Solutions at Lenovo. And just a little bit about myself before we get started. I always find that it's kind of nice to know a little bit about who is talking to you, and that it's easier to understand where they're coming from. So my name is Brian. I live in Texas. I have one wife, one 17-year-old. I have three 10-year-olds, a small dog, and a toad. I've been working with operating systems and system architectures of all kinds for about 25 years now. And big data is something that is it's a really exciting frontier that we're all venturing out into. Most recently, I was the leader for the HPC Center of Competency for Lenovo North America. And this past summer, I started recognizing how much interest was happening around big data. And we had been including, for years now, we had been including a portion of our HPC designs as dedicated for Hadoop or some sort of big data solution. And I said, you know, we need to, that's an area that I would really like to put some additional focus. So with that, let's get started. So for today, we'll talk a bit about what is big data, what does it mean, what can it do for you. We'll talk about how does that translate into software, what are the kinds of software that are involved in a big data solution. We'll talk about hardware that lends itself well towards use in a big data system, and a little bit about why. And then we'll talk about Lenovo big data offerings. And I think that for if you have questions anywhere throughout, don't hesitate to raise your hand, and I will let Kevin interrupt me at what he thinks are appropriate times, and we'll jump into a few questions. But we'll also have some time at the end to go through as many questions as we have time for. So with that, what is big data? Well, it's one of those terms that can really lead you down a rat hole of contemplation of, you know, it's kind of like the term cloud. What does cloud really mean? And it can be, it's used to refer to so many different things that it can be very abstract. And so big data can be the same way, but I think if we were to try a relatively succinct way of looking at it is that big data is when you have a set of data that is either big enough or complex enough that it makes it difficult to process or manage using classic methods, like a classic SQL database or data processing applications. From a software perspective, it's made up of many different pieces of software, and we'll take a deeper look at that in a minute. But I'm sure that most all of you have heard of Hadoop and probably also Spark. And these are two of the most popular big data solution frameworks. So in big data, you will often hear about these V's. So some people talk about 3 Vs, some 4 Vs, some 5 Vs, but the idea is that there are a couple of different characteristics to the data that we're dealing with that make it complex or big. And so, of course, there's the scale. We've got lots of data coming in. And the thing is, it's lots and lots and lots of data, but it's useful if we can find a way to handle it, to catch it, to store it, and then also to analyze it in an efficient way. It's also coming in fast. We have data coming into our organizations in many, many different ways today. In the past, most data that got into a corporation's systems was typed in by people who did data entry work. And so it was small in its size, and it was very well structured. If people are typing in the data, they're generally going to be going through a form, or at least a spreadsheet, and so the data tended to be very well structured. But today, we're collecting data from all different kinds of sources. Everything from automated systems like temperature sensors, or even monitors on power meters on the outside of a building. Everything from that to web clicks. Where are my customers clicking on my website? Where do they tend to click after they've clicked first? And how long are they pausing between clicks? And how can I use big data to predict what their behavior is going to be next so that I can intercept that and anticipate and provide them better what they're already looking for anyway. And then we have variety. With variety comes many different kinds of data types. Instead of having the very well-structured data that fits neatly into a classic SQL database, we're now talking about things like photos that people have taken. And maybe it's photos of receipts, or there's even, if we're looking at different kinds of data, there's a new feature for those of you that have Android phones. With the latest release of the Android OS, if you simply hold your phone with the camera open over a business card, it'll recognize it as a business card, do optical character recognition on it, and give you the opportunity to add that to your contact book. That's pretty cool. So one example of the variety would be if you were a trucking company. You might have telemetry information that you're pulling off of the vehicles, GPS data, where they're going, tire pressure sensors, all kinds of things like that. And these are things that we would consider semi-structured. Maybe it's log information coming off of the devices. But then
Brian, did we lose you? For some reason, his phone dropped. He's dialing back in. He'll be back shortly.
I'm back. Kevin, are you able to hear me?
I can.
Excellent. Okay. So we have an interesting example of a trucking company where you have multiple types of data. Semi-structured data, for example, could be telemetry information off the trucks, things like, engine temperature, tire pressure, GPS data. And a lot of that could be in a semi-structured format. So maybe it's the format that those individual sensor devices use when they're logging the metrics that they capture. But then you also have a different kind of data that you could be capturing at the same time. Let's say that you have some cameras that are mounted facing the driver with facial detection capability. You want to be able to detect when the driver closes their eyes so that you can do pre-sleep detection and maybe do something like, spray a mist of cold air in their face to wake them up. All kinds of interesting possibilities here. And trying to detect a face in an image or a video stream is way outside the scope of dealing with the kind of structured data that you're used to seeing in an SQL database. So if we look at the classic approach to data processing, you have SQL databases, Oracle, MySQL, Postgres, things like that. And in this model, you take your data, you store it in the database, and then you have separate application servers or maybe even a desktop application that pull the data out of the database to the application. It gets processed there, and then changes get written back. So there are a couple of inherent limitations built into this model. One of them is that what is your ability to scale within that database? So from a software perspective, or even if we say the software is capable of scaling up as big as the hardware can go, how big can the hardware go? There's still a limit. And then how fast is it reasonable for that hardware to get the data out of that one database server across the network to the application servers? So then you look at making your environment more complex, and you add additional database servers, and you get into some really expensive software models like Oracle RAC to parallelize access to a single database, or some complex models where you're trying to artificially spread the data across a series of databases that act independently. So if we look then at the paradigm shift that is possible with big data, rather than having all of the data stored on expensive SAN storage behind a small number of database servers that are the funnel through which all the data must be read and written, we now write the data to a file system that is distributed across all of the nodes in the big data environment. So this gives you the ability for effectively unlimited expansion of the system. But now the really interesting thing is that the application can also be distributed across the same nodes. So instead of moving the data from the database server to the application with the classic model, with the big data paradigm shift, we're now able to move the application to the data. So this gives you a significantly improved ability to scale laterally. It also means that the hardware that you're using is no longer very expensive, centrally managed SAN hardware, but rather inexpensive SATA disks or SSD drives in individual machines, which also makes expansion much easier. So let's take a look at what the implications are from a high availability and an application performance perspective. So HDFS, or the Hadoop file system, is the file system that is used most often in a big data environment. And so one of the things that it handles is fault tolerance. If we write a block of data, which we have represented here in yellow, so if we write one block of data to a node in the big data environment, the HDFS file system will say, I need to have additional redundant copies of that, and the typical number of replicas is a total of 3. So you've got the original one and then 2 additional copies. So the HDFS file system is going to say, I want to make sure that I have that copy on, ideally, another machine. So here's machine 2, and ideally a machine in a different rack. And so if you have one machine, it'll make 3 copies onto 3 different disks, and these disks are not in a RAID array, they're independent disks. If you have 3 machines within one rack, it'll make 1 copy to 1 disk in each of 3 different machines. And if you have 3 racks of machines, it'll make 1 copy to 1 disk in 1 machine in rack 1, a second copy to 1 disk in 1 machine in rack 2, and so on, so that you can even lose an entire rack in that scenario without actually losing any of the data. So one of the natural questions is, well, gee, that's a lot of redundancy of data. If redundancy of the file system is the only requirement, that seems like a lot of extra storage space that could be used for something else. But it turns out that the other thing we're now able to do is when we're running our application, the application knows where the data is. And so through the Hadoop framework. And so the application is now able to be run on any one of these 3 data nodes. Or if the application is able, it can be split so that 1/3 of the application is run on one, another third on the second node, and the final third on the third node, so that in effect, the application ends up running 3 times as fast as it would have before. So big data has implications for virtually every industry. In a recent month, I was talking with an internet software service provider out in California about big data solutions, to an investment bank in the Northeast, and even to a major auto manufacturer, all looking at using big data solutions to help them to get ahead and win in their area of the market. So what we're seeing is huge growth in data. One of the most striking numbers that I've heard is this one on the top left. If we look at all of the data that's out there, 90% of the data that exists today did not exist 2 years ago. And the rate of that data growth is increasing. Our ability to take advantage of that data that is being generated is increasing as well. One simple example is if you've ever used Google Maps and you've searched for a place that you think you might want to go to, if you click on the details, it'll show you popular times for that location. Well, how do they know what time is popular? Well, they're not sending people out to ask each business, what are your popular times? They're able to, because you have agreed to have your location services turned on, they can tell anonymously when are the times that most people that are using their services are in proximity of that location. And then based on that, they can extrapolate, these are the times that are most popular for this restaurant or business. And then that helps you to make a decision about what is the right time for you to go. So the big data market is growing, and it's big already. In 2013, IDC stated that they predicted the 2014 worldwide market for big data would be about $16 billion. At the end of 2014, they predicted that the worldwide market for big data would be $125 billion in 2015. So it's growing very quickly. And what we're seeing is that customers deploying big data solutions are realizing a return on their investment very quickly and are able to make better business decisions because of it, or more effective interaction with their customers, and they are coming back and purchasing more and more. So let's take a look at some big data software. What does it look like? So we have this thing called Hadoop. And back in 2003, I believe it was, Google released a paper in which they described a new way of handling the vast amounts of data that they were collecting as they scoured the World Wide Web to improve their ability to be a search engine. And what this paper was describing was a thing called MapReduce. And this paper was, it described a method of doing what we would now refer to as a big data architecture, but it didn't include software. And they continued to develop their own software internally, which is based on that model. Yahoo, though, developed software that achieved those same principles, the same fundamental methodologies, and open sourced it. And they called it Hadoop. And it is a project as part of the Apache Foundation. If you're familiar with the Apache web server, it's the same open source software group that includes Apache, the Apache web server. And Hadoop was the name of a toy elephant that one of the original developers' daughters had and played with. So Yahoo adopted these technologies, used them internally, published this open source software, Hadoop, based on it, and it proved to be incredibly successful. And Hadoop is a framework that includes many different components. One of those components is HDFS, the file system that allows you to distribute the data in a fault-tolerant way across many different independent nodes, and then to provide applications with a map to know where to access the data that they need. It also provides a number of other components, and one of them is a MapReduce framework. Now, this is growing so quickly that Spark is already a next generation of a MapReduce infrastructure that you can use for those certain key components within a Hadoop framework or within a big data distribution solution. It doesn't replace Hadoop. It has the ability to provide a better form of some of the same capabilities that Hadoop does, but it is designed to work with Hadoop. And so you would still use an HDFS file system even if you're using an application that runs on Spark. So I mentioned that there were lots of different softwares in the big data space, and boy, that's a lot of softwares. And there's more that are coming out every day. So one way to look at this is that Hadoop is, and Spark and things like it are like the core of a big data solution. And there are many other softwares that can tie into that to leverage the data that's there and process it in their own special way, or as an auxiliary system for pushing data in or pulling data out. And so you end up with many different applications that have similar capabilities, and it can be really baffling as to which one to choose. I mean, think about email. You have an email client on your Android phone or your iPhone. You've got an email client on your desktop, or maybe even, you know, you're accessing your email through a web interface, but it's all coming off of the same mail server at the back end. So there are many different ways to access the same data, even doing the same basic function, but each with, you know, slightly different characteristics. So how do you choose? And so that's where the big data distributions come into play. Cloudera, Hortonworks, IBM's Big Insights for Apache Hadoop, and MapR are the four top big data distributions, and you can think of them in the same way that you would think of a Linux distribution. So at the core of them, they are including the same fundamental components. So if you look at SUSE Linux versus Red Hat Linux versus Ubuntu Linux, they are all based on the same Linux kernel. They all have many of the same open source softwares included, but each of them is maybe using a different kind of packaging mechanism. They may have a different management methodology for administering the system, and they have chosen the specific pieces of software that they believe work best together and are supportable. And then they wrap their own support offering around that, as well as services. And so the big data distributions can be thought of in the same way. While it's possible to go out and create a big data infrastructure by picking and choosing individual components straight from the upstream open source sites, like from apache.org, it's definitely much easier, and generally speaking, you're not, there's no reason not to for 95% of the people out there to leverage the management infrastructure that's provided by one of these big data distributions, and also some of the unique capabilities or services that each of them has to offer. So let's take a look at the hardware that you would choose to run your big data solution on. So within a Hadoop cluster, you generally have two different kinds of nodes. Now, for experienced big data users, they may find that there are certain specialty purposes or applications that they want a certain, another kind of node defined, but it generally will still fall into one of these two categories. So the management nodes are the ones that are coordinating the activity within the cluster. And to be clear, this is management of the big data softwares and the big data software stack that runs across all of the cluster, not necessarily management of the operating system on the nodes themselves or the hardware of the nodes. And so we'll often couple a cluster management solution in addition to the big data solutions management nodes and the software that runs on them. Then we have the data nodes. And the data nodes is where the really exciting stuff happens. And they're generally characterized by having lots of independent local disks. And HDFS takes advantage of those. Despite the fact that they are independent, JBOD style, through HDFS, it's able to achieve the redundancy. And a classic rule of thumb would be that you want to have at least one core per spindle. And the way that Hadoop writes data to the drives through HDFS is in a streaming kind of fashion, and with really big block sizes, like a 128 megabyte block size is the de facto standard. So you are often not as worried about IOPS and more about streaming performance. And so having one core per drive spindle seems to be an appropriate general purpose balance. I apologize, the clicker button for moving to the next slide is very small and hard to click. So what does a complete solution look like? Here's an example. This could be an example that represents one of our Lenovo reference architectures, as a matter of fact. So starting at the bottom, we have our data nodes. And these guys are where all of the data is kept. We have the management nodes. Management nodes will typically use our 1U 3550s. For data nodes, the 3650 is the one that generally fits the best because of the number of spindles that we can include in it. And then at the top, we'll have a couple of different kinds of switches. We'll have a 1U switch for out-of-band management and provisioning and the main operating system. And then we'll have a 10 gig switch for the data network and movement of data around within the cluster from node to node. So one of the great things about a big data solution is that it is laterally scalable, and operation, as you grow, your ability to expand online without taking the system down is incredible, and it's very easy. Expansion is simply a matter of adding the additional resources that you want to include, such as in this case a full rack of expansion nodes, and then telling the management nodes, here are some additional nodes that you can incorporate into the cluster. And then as jobs are running across the system, the management nodes will naturally start sending jobs to these new data nodes and start writing data across the drives in the new data nodes. So what does Lenovo have to offer? So of course we have excellent hardware. We have reference architectures, and we also have competitive pricing. If you are one of our customers that is viewing this webcast and you'd like to know more about that, please reach out to your Lenovo salesperson, and they will be glad to talk to you about that. So let's take a look at the hardware first. Lenovo hardware is ranked very well in the industry. We are the #1 in reliability, and we didn't just pop up there for a short while. We've been there for a long time, and it's been very purposeful. We are also #1 in customer satisfaction. From a independent
Did we lose you again, Brian? Well, I'm sure he will join us again. That's the second time he got bumped.
Okay, back again. So our X3650 M5 is our flagship big data node, and I can anecdotally say that I have been told in an unofficial capacity by certain customers and software vendors that they consider it to be the best big data node on the market. Some of the characteristics that it has is, we have the ability to have 14 up to 8 terabyte drives in the system. So that's a huge amount of capacity. Or within the same node, just a different disk layout type, we're able to get 26 2.5-inch drives. And for those of you that are looking at this and you're counting and you're saying, wait a minute, I don't see that many, the back of this node has the ability to host additional drives. And often those are only used for booting purposes, but they can be used as part of the data storage as well. Other booting options with these that make them very flexible is you can do a RAID level 1 SD card for booting, so you can take advantage of all of the drives. And you can have a system with a mix between the 3.5-inch drives in the front and either 3.5 or 2.5 in the rear. From a speed to the disk subsystem perspective, as we've covered, HDFS wants a bunch of independent disks, so JBOD style. A lot of vendors will take a hardware RAID controller and then tell it to operate in JBOD mode and use that to access all of the disks underneath. But what we find is that we actually achieve the fastest performance when we use a non-RAID 12 gigabit SAS controller, such as what you see here, because we're able to bypass, so even on a hardware RAID controller, when you are exposing individual LUNs as individual, or exposing individual disks, each as a single LUN, so that it looks like it's just a bunch of disks, you're still passing through the RAID level subsystem layers, and it imposes a performance penalty. And so we're able to get the best performance by bypassing that altogether. Oh, and one quick comment here. On the data nodes, we don't need fault tolerance, or we don't need RAID-based fault tolerance for the storage, but there are a couple of places where you do, such as on the management nodes, where you're storing certain metadata about the entire HDFS file system, for example. So in addition to the node hardware, the big data nodes, our 10 gig switches are a very cost competitive option that provide excellent performance and very low latency. And the 8272 is a relatively new addition to the lineup. And you'll notice that, so it's got 48 10 gig ports, but off to the far right side, there are 6 40 gig ports. So a common way to lay out a system is with 2 of these in a rack, so that each of the big data nodes is connected once to each of the 2 switches in a fault-tolerant bond, and then those 2 switches are trunked together. And by having, and then as you add additional racks, you want the additional racks to be connected together at 40 gig. Because of the having 6 40 gig ports on this switch, we can expand to several racks before we have to introduce another tier of switching into the infrastructure. The 1U servers are typically what we would use for management servers, but that can also be done with the 2U nodes as well. So one of the things that Lenovo does is we work with our big data distribution partners, and we have put together reference architectures that are Redbook style documents that detail a full architecture down to every part that you would need to put a system together, every part number and quantity count, so on, with diagrams for how the networking should be laid out, and even installation and tuning details. So today we have reference architectures for IBM Big Insights, for MapR, for Cloudera, and we're looking to get a Hortonworks reference architecture added in the near future. So as part of the reference architecture and friends, we'll say, we have an architecture brief. So this is, like a 4-page data sheet style introduction to a Lenovo reference architecture, while the reference architecture document itself might be a 40 to 60-page document. Both of these kinds of documents, the reference architecture document and the architecture brief, can be found if you go to this website here. And I would encourage you to go out there and take a look. Going beyond the predefined reference architectures, which, by the way, the reference architecture documents describe both textually and visually the solution, as well as why it was done, why that architecture is put together the way it is. And we also have, for use by our business partners and our Lenovo architects, predefined configurations that match those reference architectures. Those make a very good starting point when putting together an actual end-user solution. Sometimes they're used as is, but sometimes they are used as the starting point and then modified in minor ways to come up with an architecture that specifically meets your needs as a customer that is still based on a reference architecture. So you have a high confidence in it being able to meet all of the requirements of your chosen big data distribution, as well as helping you to be successful in accomplishing your goal through your big data deployment. When we deliver a big data solution, it can be delivered, manufactured in our factory, in rack, with all of the components fully assembled, cables run point to point, Ethernet cables cut to length, very tidily tied, labeled with point-to-point information, and so that when the system is delivered, you can simply roll it out of the crate onto your floor, plug it in to power, plug it into the network, and then have our professional services team come out to deploy the system. It can save you a huge amount of time. So from a professional services perspective, the Lenovo Professional Services team offers deployment services for big data solutions, which includes everything from making sure that the latest certified to work together within a clustered environment firmwares are in place on all of the components, from networking switches to InfiniBand switches, should you be using those, and the nodes themselves, getting the operating system installed, and doing a standard style deployment of the big data distribution as well. Going beyond that point, we would look to engage one of our big data distribution partners or one of our value-added resellers to assist with application integration from the big data distribution stack on up. We also have the ability to offer managed services. This is a relatively new offering for us from a big data perspective, and so we are evaluating these opportunities on a one-by-one basis as they come along. So if this is something that you're interested in, please reach out to us and let us know. So with that, I will say thank you, and let me open up the call to questions.
We got one here. I'm forwarding it to you.
Okay.
Send it to me, but there you go.
Okay.
Can you read that now?
Yes. So looking at the architecture brief, it lists hardware, for example, Cloudera distribution for Hadoop. How strict are the specs? So, okay, so how strict are the specs? How flexible can we be? Disk processor, et cetera. Also, is the hardware listed the minimum requirement, meaning that the nodes quantity starts at 9? Okay, good questions. So first, let me start easy and build up. The minimum number of nodes to have a functional big data system is 1, essentially. But practically speaking, so you can go out to any of these big data distributions sites and download a sandbox virtual machine or a Docker container and give it a try within that restricted environment. But to truly take advantage of, if you're looking at it from a business perspective, then in order to have really a functional system that puts you at the point where you're ready to really scale out, you'd be looking at a 3-node configuration. And so I believe that if you look at the Cloudera distribution for Hadoop reference architecture, as opposed to the architecture brief, I think you'll see that the number of nodes it includes, the number of data nodes, I believe is 3. And it'll still have a couple of management nodes. Now, moving up from there, these specs are intended to target the 95% use case. So in terms of how strict are they? So they can all be changed, but the implications of changing them are potential negative ramifications or positive ramifications in performance. So if you drop the memory too low, that can have a significant impact on performance. You could increase the processor speed. And making these kinds of changes are not necessarily going to take the big data solution out of spec from a supportability perspective. And so this is why this is a certified reference architecture. It is a solution that is intended to achieve the performance and capacity goals of the 95% sweet spot as a general purpose system, and is well balanced in that regard. But that said, making tweaks such as, probably the most common tweak to make is the size of the disk drives, okay? A second common tweak to make would be the speed of the processors. If you are not sure, then please reach out to us, and someone from our Big Data Center of Competency can work with you to help you to determine what are appropriate adjustments to make for your particular scenario. Okay, let's see. So we have another question here. Would a data node, according to Lenovo best practice, have a non-RAID controller for the data drives and a separate RAID controller for the OS? And the answer is yes, that is the way that that is what you will actually find in our reference architectures, is that on the data node we'll have an inexpensive hardware RAID controller that is able to do RAID level 1 for the OS drives. But I will comment here a couple of best practices. One is, depending on your environment, you might decide that it's useful to do one of two things. One is you can use faster drives for the OS so that you can improve booting performance or provisioning performance or other. And in one case, SSDs are used in one of the reference architectures. Another theory is to use the exact same disks that you're using in the data nodes for HDFS for the operating system also. And the advantage in doing that is that you only have one disk type that for for support purposes. Anytime that you're calling in to get a disk replaced, it'll always be the same kind of disk. And so there's some operational advantages to that. Other questions? Okay, let's see. So we're talking about services, and yes, so the question is, when you talk about services, can I assume you mean the lab services offering? And the minimum for that is 3 days when purchasing, but is there a mandatory number for a big data system? Okay. So first, let me say that, so lab services is the name that has been used for a long time to refer to this group of people. The Lenovo professional services team, and that name has been moving over time towards simply being professional services. And so that's how I'll refer to them now. And yes, there is a minimum of 3 days for Lenovo professional services. But is there a mandatory number for a big data deployment? For any deployment, so there's not a specific mandatory number, but what will happen when you have a big data solution that you want Lenovo professional services to deploy, they will do a sizing, which will take a look at the complexity of the solution and what you need them to do in terms of connecting it to the rest of your infrastructure. And they will produce a statement of work that describes everything that they will do, and which will include how long they believe it will take, and that will result in the number of days that becomes, that would be billed for those services. And typically, it would not be longer than, let's see, I have got another slide here, but I believe that it'll generally be more than 3 days, but I want to say less than a week. Are there, do we have another question?
None so far.
Okay.
Whoop, and just got another one.
All right.
There you go.
Okay, so what about the operating system? I assume that is what we have to manually add onto the configuration. Okay, so that's a good question. The big data distributions have the ability to, and I'm making a general statement here, they have the ability to be installed as packages on an operating system. And so, though you would need to have so if you were installing packages style, you would need to have an operating system that matched with the packages that you were installing from. So in other words, you would need to have, Red Hat or CentOS or similar if you were installing, Red Hat 6-based RPM packages. But it turns out the big data distributions, for the most part, are not so concerned about the exact distribution that you use. And they actually tend to recommend using a deployment method that is what I would think of as bundles, software bundles, rather than operating system-based packages. And this allows them to use the same methodology for managing through the big data distribution management nodes. It gives them the ability to use the same methodology to manage the big data software stack independent of the specific operating system distribution that you're using underneath. So that said, the reference architecture documents should call out if there's a specific requirement on operating system, but generally speaking, you can use Red Hat or CentOS or Scientific Linux or SUSE or Ubuntu. And our standard go-to would be Red Hat 6 or Red Hat 7. And if you are a site that prefers something else, then we can work with you on that. And so if you're a business partner or a Lenovian putting together a solution and you wanted to include the software in that, then yes, when you have the configuration open in Xconfig, you would just make the operating system software selection that was appropriate for that customer. Next question.
Yep, one more just came up. Like one question leads to another. There you go.
No, questions are fine. Ask away. Okay, let's see. So what tool is required for this? Let's see. I think I'm not seeing the whole question here. Let me open my window a little further. Okay, here we go. Okay, so the question is, what tool do we have to use if we are putting together a big data configuration? So the answer is based on how do you want the solution to be delivered. So we're flexible and we'll allow you to do it in multiple ways. The preferred way, and the way that I would highly recommend, is to have the solution delivered, as I had mentioned earlier, as an integrated solution that was put together on our manufacturing floor and then shipped in rack, pre-cabled. And one of the advantages of that, by the way, not simply, well, I'll call out a couple. One of them that's fairly obvious is you don't have all of the dunnage from the boxes of all of the individual components. A second one is when you order it as individual components or systems, different parts may ship at different times. And the third one is if you order it as an integrated solution, then we can also do stress testing on it before it ships. So we will run code on the nodes and stress, we'll be testing the network, and we'll be testing components within the nodes to do things like provoking infant mortality of components, like memory DIMMs. And that's good for us, and it's good for our customers. If we can provoke a memory DIMM failure while it's on the manufacturing floor, then that's a failure that is not going to happen once we get it to your side as a customer. But it also turns out it's a whole lot less expensive for us to have somebody on the manufacturing floor simply walk over to the machine, pop out the DIMM, and pop in a new one than it is for us to put somebody in a car and send them across town or even maybe to another city to do the same thing. So that one's a win-win. Okay, back to the tool. If you are going to create a configuration that will be manufactured as an integrated solution delivered in a rack, Xconfig is the tool, or now we call it LESC offline. And I think that's the Lenovo Enterprise Solution Configurator. Because our other main tool, which is LESC Online, does not currently have the ability to describe the relationship between components. So with our online tool, LESC Online, you can, or before that, SSCT, you could create a complete solution as an individual box and describe all of the components in that node, for example, but you didn't have the ability to say, here, take that node and put 20 of them in the rack and make sure that the second Ethernet port on each of those is connected to this switch in this other rack, and create a relationship between the components. And so that is the reason why LESC offline or Xconfig is required. For those of you that are interested in that, I will, I've got a URL to a short demo that shows how to use LESC offline to pull one of our predefined reference architecture configurations and open it up in that tool so that you can then make some modifications. While I'm looking that up, are there other questions?
Haven't seen any come yet.
Okay, great. So I am almost there. Okay, here we go. I'm going to paste this URL in and let me say send this to, so should I say, oh, send it to everyone. There we go. Okay, so that YouTube video is like a 3-minute demo of opening a predefined big data reference architecture configuration using LESC offline, or as it has been called in the past, Xconfig. Any other questions before we wrap up for the day?
None that I'm seeing pop up here. Feel free to type them into the chat box.
Oh, and you know, I should say that when you open up the configuration, if you watch that video, you'll see how you can open up the configuration to make changes to it, but there's also a mention of how you can simply click on a button to simply get the parts list. So you go through that process of opening the predefined reference architecture configuration, and you just hit the, I believe it's the export button, without even, you know, having to know anything about the tool. You end up with a spreadsheet that details every single component and quantity and part number that if you are wanting, let's say that you're one of our business partners and you're wanting to put together a solution and acquire it as components and do the assembly, it will give you everything that you need to complete that process. So I guess we'll do should we do a last call for questions? And if there are no more questions?
I don't see any. I think we've you covered it very well today, Brian. Okay, very good. I appreciate that. If you want to send me the slide deck that you presented, I will get that posted up on the user group site so that everybody can see that and access it, and then the replay also.
Absolutely. I'd be happy to. Thank you very much, everybody, for listening to me ramble this morning. I hope you found it useful. Again, if you have additional questions, don't hesitate to reach out to your local Lenovo sales contact, and we'll get you routed to the right people to give you what you need.
Brian, thank you for your time today. We really appreciate it.
Thanks, Kevin. My pleasure. We'll talk to you guys later.